Hello, everyone, and welcome to another Memgraph Community Call. It's a bit different today because you can see that there are two persons next to me, at my screen at least. So we have Laurie Voss from LlamaIndex, VP of DevRel, and we have, hi Laurie, and we have Matea from Memgraph Developer Experience Engineer. It will be, I think, really fun and educational community call. And to kick off, Laurie is going to share his presentation about Llama, how it works, what they do, and how it actually correlates to the stuff that we are doing. And that's where Matea will jump in and tell us a bit about knowledge graphs, how did we integrate with LlamaIndex, what's next, but I don't want to spoil a lot. So I will leave the stage to them, but just a small information before we start. I see you notice that we have a chat. So hello to everyone. I see you're coming from all over the world. Greetings to all. We also have a Q&A section. So if you have a question, please post it there. It's not a problem if you post it in the chat, but it will be easier to manage if you post it in the Q&A section. So once both Laurie and Matea are done, we are going to go through that Q&A and pick a couple of questions to talk about. We'll see how much time we'll have left. And I will also be posting a couple of polls, so you'll be able to see that section as well. I'll keep you posted in the chat about that. But other than that, I think that's it. And I don't want to waste any more time. So I will leave the stage to Laurie. Thank you, Laurie, for joining this call, and thank you for agreeing to talk with us. And the stage is yours.
Thank you, Katerina. Let me share my screen. And let's get to it. So hello, everybody. I'm Laurie. I'm VP of Developer Relations at LlamaIndex. In a former life, I co-founded NPM Inc., so some of you may know me from then. These days, instead of talking about JavaScript, I talk about AI. Specifically, today I'm going to be talking about RAG, specifically GraphRAG. First, I'll introduce you to LlamaIndex, and then we'll cover the basics of RAG, what GraphRAG is, and how GraphRAG can work in LlamaIndex. Then we'll talk about why we need agents and how to build those in LlamaIndex as well. And finally, we'll talk about workflows, which is a key abstraction for building fully fledged GenAI applications. So we're going to cover the whole gamut of a RAG-based application. So what is LlamaIndex? It's a bunch of things. Let's start with the most obvious. We are a framework in both Python and TypeScript that helps you build generative AI applications. By generative AI applications, we nearly always mean knowledge assistance, software that augments how we fetch and use information. Both of our frameworks are open source and free to use, but that is not all that LlamaIndex does. One of the other big things that we do is a service called LlamaParse. What it does is it parses complicated documents in any format. So think PDFs, Word, documents, PowerPoints, things like that. This is critical for lots of GenAI applications because if your LLM can't understand what it's reading, it's going to get nonsense results. This is particularly important for GraphRAG, as we'll see. LlamaParse is also free to use for 1,000 pages a day, so it's easy to try out. Then we have Llama Cloud, which is our enterprise service. If what you want to do is stuff your documents in one end and run retrieval augmented generation on the other end without having to think about the stuff in the middle, then this is the service for you. You can think of it as LlamaIndex building a LlamaIndex application for you. You can sign up at cloud.llamaindex.ai, the same place where you use LlamaParse, but some of the features require signing up for our waitlist, which you can find at this link. Then there is Llama Hub, which is our registry of helper software. If you need to connect to any database in the world to get your source documents, we can do that. If you need to get your data out of Notion or Slack or Salesforce, we can do that. If you need to store your data in a vector store, we support all of them. If you want to use OpenAI or Mistral or Anthropic or some other LLM, we support over 30 different LLMs, including local ones like Llama 3. And if you want to build an agent and want some pre-built tools to do that, we have dozens of agent tools already built for you. So overall, why should you use LlamaIndex? It's because we will help you go faster. You are a developer, you have limited time, you have actual business and technology problems to solve. You don't want to get stuck figuring out the basics. So we've solved a bunch of the foundational problems for you, so you can focus on actual business problems. What does LlamaIndex actually do is we help you build agentic RAG. But I haven't said what RAG is yet, and I haven't explained an agent either. So let's go into what I mean by both of those things. Retrieval augmented generation is a response to a fundamental limitation of LLMs. LLMs are trained on vast quantities of data, but they are not trained on your data. To answer questions about your data, you have to give them your data, but LLMs have limited context windows, and you have huge amounts of data. So you have to be selective about what data you give them. You can't give them all of your data every single time. That would overwhelm them. In retrieval augmented generation, you find a way to select relevant information, the information that is most likely to answer the question, and you give that to the LLM as its context. But the trick is, how do you select the relevant information? There are a bunch of ways to find relevant information to give to the LLM. An extremely popular way is semantic search. It is so popular that this is usually what people mean when they just say RAG without qualifying it. I'm not going to go into a full explanation of semantic search-based RAG today, but the idea is that you encode all of your data into a vector database, which stores things according to what they mean. And then when you query something, it looks for things that mean the same thing as your query and use that as context. Another way that you can do RAG is by using text to SQL. Say you have a really big relational database with all of your data in it already. When you run a query, you can give the LLM the schema of your database and get it to write a SQL query that will fetch the relevant tables and rows and provide your context that way. And the third way is the way that we're going to be talking about mostly today, which is GraphRAG. In GraphRAG, you convert all of your data into a graph. You're in the Memgraph Community Call, so I assume I don't need to explain what a graph is. But you use the relationships in your graph to help retrieve your context with which to answer your questions. We're going to talk about exactly how to do that in a second. Let's talk about how you build a RAG pipeline. You ingest your data from where it is stored. You parse it into an LLM-compatible form. You store that data in an index. And then when you're ready to query, you retrieve data from your index and you pass that data and your query to the LLM. Then the LLM generates a response. In semantic search, this index is a vector store. In text to SQL, the index is a relational database. In GraphRAG, that index is a graph database. An important part of this pipeline in GraphRAG is constructing the index in the first place. In GraphRAG, this is also an LLM-powered step. You get your LLM to read your content and instruct it to extract entities and relationships. It then uses those to construct your graph, writing it back to your graph database. And there is a ton of subtlety in how exactly you do that. With your graph constructed, it's time to query from it. There are several ways to do that, one of which Matea is going to be demonstrating later. But the first way is just vector retrieval or semantic search, which is the same thing we were talking about earlier. Some graph databases support retrieving nodes that are semantically similar to your query and then fetching the context connected to them. Another way is text to cipher. This is kind of like text to SQL. You get the LLM to read your query and the schema of your graph, and you generate cipher queries, which it uses to query the graph and fetch relevant context. And the final way, which is the way we're going to talk about today, is synonym retrieval. In this version, you get the LLM to take your query and convert it into entities, and then you get the LLM to create as many synonyms for those entities as it can. You then query for all of those entities and synonyms to get as much context as you can. And that is the thing that we'll see in the demo today. But a very important point I want to make is that we are trying to solve a problem here, and that problem is knowledge assistance. RAG is part of the solution. It is an extremely important, magically powerful part of the solution. But there are some things that it can't do, and there are some ways that it can fail. One task that RAG is not great at is summarization. If you've got an entire document, the query summarize this is going to try and find a summary. If that's not already there, it's really going to struggle to summarize. In semantic search terms, it would need the whole document. In GraphRAG terms, it would have to fetch the entire graph. Another task that's tricky for a basic RAG pipeline is comparison. If you've got a bunch of data about multiple people, like candidates in a recruitment database, for instance, and you ask RAG to compare them, it's going to use that as a query. It's going to try and retrieve information about both people in one shot. And that's going to limit how much you know about each person. And it also creates the potential for them to get mixed up if there are multiple chunks about each person in the same retrieval. And more generally, a thing that naive RAG fails at is multi-part questions. If you ask a naive RAG pipeline to summarize the arguments of article A and the arguments in article B and put them in a table and compare them, it's going to get very confused just trying to do all of that in one go. Which isn't to say that naive RAG is bad. It's very useful for many things. It's necessary to get a lot of stuff done. It's necessary, but it's not sufficient. Lots of tasks require RAG, but lots of tasks require more than that as well. So how do we go beyond the limits of RAG to fully utilize the power of LLMs? There's two avenues of improvement that we can follow here. The first is to improve the data quality, and the second way is to make your querying more sophisticated. We're mostly going to be focusing on the second one. The way that we're going to be improving our querying is by using agentic strategies. But what is an agent? Agents is a term overused in this industry to the point of meaninglessness. But what I mean when I use it is semi-autonomous software that can be given a goal and will work to achieve that goal without you knowing in advance exactly how it's going to do that or what steps it's going to take. Let's talk about agentic strategies and how we can build them into our system, working our way up to a full agent. A naive RAG pipeline has a bunch of limitations. It's just single shot, so there's just one question and one response. There's no query understanding. It doesn't natively understand what it's being told to search for against the text of the query. And there's no tool use, so you can't go and seek more information. There's no reflection or error correction. So the pipeline does not check whether it really answered the question adequately. And finally, there's no memory. Every question is brand new with no memory of previous queries. And we can fix all of those. By building agentic RAG, you can do a whole lot better on every front. You can make your queries multi-turn. You can have the agent understand the question and plan how to get the answer in multiple steps. You can make RAG just one of many tools, allowing you to interface with the wider environment and other sources of data. And you can use reflection to figure out if the response is adequate and course correct if not. And you can have memory so that each step towards the solution becomes part of a larger context. Getting all of that done is a lot of work, but that is the work that LlamaIndex is designed to do for you. These strategies that I'm talking about exist on a spectrum of complexity. Some are very simple to implement and don't require too many calls to the LLM, but others are more advanced and require lots of calls to the LLM. And that will also increase your monetary cost and your time cost in terms of latency. So you don't necessarily want to automatically build the most complicated agent that you can think of. You have to make trade-offs for your application. Let's break down these strategies and go through each one of them in turn. The first step is routing. This is the simplest form of agentic reasoning. Given a query and a set of basic tools, the router uses the LLM to select which is the best to answer the question. This can solve the summarization problem by making one of the available tools a full document or a full document summary rather than search. The next tool that we can add as we build up to an agent is memory. This is theoretically simple. As you run queries, you include them in history, and you pass the history as context to your further queries. This is basically how chats work with like GPT. In practice, it gets more complex. As your history begins to overflow the size of the context window, you have to get clever about condensing the history. Then we can add one-shot query planning. This takes a complex question and breaks it up into a series of simpler questions which can be run in parallel without conflict with each other. You can then take the resulting responses and get the LLM to aggregate all of these responses into a single response based on far more context and trying to do it all at once. This is great for comparison. The router query engine and the sub-question query engine are two specific examples of the biggest part of making agents and agentic RAG effective, which is tool use. You can describe an arbitrary API to an LLM and get it to infer the parameters of that API and then get it to call that API. The result is that you can get the state of the world, not just documents. You can even modify the state by taking actions. Tool use doesn't just pass a query, it adapts the query to the tool. In auto retrieval, for instance, it takes the query and uses it to decide how to pre-filter the data by using keywords in the metadata. If it's talking to a SQL database, the query is transformed into a valid SQL query, or of course, if it's talking to a graph database, it can transform it into Cypher. And if it's talking to another application like a calendar, that query can become an API call to that application. So now we've seen the basic agentic strategies: routing, memory, planning, and tool use. But these are just the minimum necessary to create an agent. We need to go further. Let's make it multi-turn. Let's give it reasoning and planning. Let's give it reflection. And let's talk about how we get those things done. There's three types of agentic reasoning loops that I want to talk about very briefly today: sequential, DAG-based, and tree-based. These also live on a spectrum from the simplest and the cheapest and sequential to the most complex and expensive variant. The first type is sequential. What you do in sequential reasoning is you generate your next step given your previous steps. This is sometimes known as chain of thought. One of the most popular patterns here is called React, not React the web framework, but reasoning plus action. In React, the agent generates a distinctive pattern. It generates a thought and it comes up with an action based on that thought of what that thought implies it should do next. It stays in a loop, coming up with thoughts and actions, trying to get closer to achieving its goal until it achieves its goal or it gives up. This is very simple and doesn't necessarily get it to a solution because it doesn't necessarily know how to get all the way to the solution from the start. Which brings us to DAG-based reasoning, which is the next step up in sophistication. A DAG is the directed acyclic graph, which if you're not familiar with it, it's easily summarized as something that's kind of like a flowchart, boxes with arrows between them leading to a goal. In DAG-based planning, the LLM comes up with a full plan from start to end to accomplish the goal of the flowchart. A critical part of this planning is the ability to replan when things don't work out. Every few steps, it can observe what's happened and decide whether or not the plan still works. This ability to self-evaluate is called self-reflection. The LLM can tell whether the LLM is doing a good job. You can, of course, also get a human in the loop to tell the agent whether it's getting towards its goal. But still, DAG-based planning works best when the task is sufficiently constrained that there's a clear route from zero to the solution. There are some tasks that are too complicated to be like that. That's when you get to a more open-ended task and tree-based planning. There are several different variants of this, including tree of thoughts, reasoning via planning, and language agent research. But they have some fundamentals in common, which is that they don't know in advance how they're going to be able to solve the problem. Instead of building a single plan from start to finish, these agents create experiments. They come up with several different next actions and execute them in parallel. Then they look at the new states generated by those experiments. Are they closer to their goal than before? How do they know if they're getting closer? You can give them an external way of measuring, or you can get the LLM to perform self-reflection to estimate how far it's getting. The agent can then select the most promising states and perform further exploration while dropping states that don't have good outcomes. This is called balancing exploration, creating new branches, versus exploitation, following the most promising path. So now we've got pretty deep into LlamaIndex. We can build a RAG pipeline. We can build agents that use RAG pipelines. And the last thing we're going to cover today is workflows. Workflows, I'm sorry if the sound is not good. There's some background noise where I am. The last thing I'm going to cover today is workflows, which allow you to build upon these patterns to create more complex LLM applications. Specifically, it allows you to create multi-agent systems, where the agents that we're building so far
can work in combination with each other to achieve more complex tasks and truly become knowledge assistants. Why do we need workflows? Why do we need this extra feature of the framework? Because when applications get big, they get complicated. And we are growing to meet that need. We need to be able to define how your agents are going to interact. You need to be able to debug and visualize that interaction. And you need to be able to customize existing flows to your own purposes. These are the problems that workflows are built to solve. The most basic workflow looks like this. A workflow is composed of steps, and you can have as many as you want. You create a class that holds all of the steps. Steps are marked with a decorator, and they use type descriptions to specify what events to trigger them and what events they emit. So in this most basic example, we've created a function called generate and marked it as a step. It accepts a start event and emits a stop event. So this flow just runs linearly. One of the more important things that you can do with workflows is you can do loops. In this simplified example, you can see how this works. We now have two steps. The first accepts the start event, and it tries to answer the question. In this case, I'm using random numbers to simulate the question. If it gets a bad answer, it emits a failed event, and it triggers the improved query step, which will try to come up with a better query. And it emits a query event, which gets picked up by answer query again. One of the neat features of workflows is their built-in visualizer. Here you can see a looping flow with self-correction. It starts with a start event and tries to answer a query. If it gets a good answer, it immediately stops. If it gets a bad answer, it tries to create a better query and loops back to answering the question again. You can create complex branches, loops, and parallel queries using workflows and easily visualize how they run. In addition to passing events around, there's also a global state that all steps share called context. This is great for your initial ingestion step where you can create your indexes and make them available to all your steps. You can see here, we're creating a vector index and assigning it to a variable called index, but you can do this with a graph store as well. As we continue to work on workflows, we'll be releasing pre-built workflows to implement common design patterns. With those in hand, you'll be able to customize them to meet your own specific needs. This is because all workflows are just classes, so you can subclass them to create your own versions, as in this simple example. So while these examples are very simple to fit on a slide, keep in mind that each step can be arbitrarily complex. You can be defining and using a RAG pipeline. You can define agents with tools, and you can use built-ins like Sub-Question Query Engine and others. So when you're building your first app, you can be linear, but as your flows get harder to keep track of, this is the tool to reach for. So that is all the time that I've got to cover today. As a quick recap, what I covered is what LlamaIndex is, what RAG is in general, how GraphRAG works specifically, and how and why we need to go beyond basic RAG to create agentic workflows to truly create knowledge assistance. What happens next is up to you. We are excited to see what you can build with all of this, and we welcome feedback from the open source community. You can join our Discord to ask questions of your peers, and also all of our engineers hang out all day. We also have extensive documentation that I've personally spent a ton of time writing, so we welcome feedback on that as well. I hope this has been a useful introduction to LlamaIndex and all it can do. I apologize for the sound issues. You can follow this link or this QR code to get all of the slides that you saw today, plus all of the links to examples. It's been a pleasure to speak to you, and thank you for your time and attention. Now over to Matea, who's going to talk about Memgraph specifically and how it fits into this picture.
Awesome. Thank you, Laurie, for the great presentation. It was really great to hear about all the LlamaIndex's capabilities. And there were some issues with the sound, but I think we'll be able to watch the recording and we'll be able to make the sound of it, so don't worry about that. So as Katarina already introduced me, I'm Matea from the DX team, and let me just quickly share my screen. A second. I'm sure there are some people here on the call that are not familiar with Memgraph, so I wanted to give you a short introduction just in case. So Memgraph is an in-memory graph database that can handle large-scale data and is suitable for the real-time analytics. Now, besides the database itself, it also includes the Mage library, which contains all of the different algorithms, and a visual tool called Memgraph Lab, where you can explore your data, visualize your queries or query outputs. You can generate your Cypher query, generate your knowledge graph and your schema and all the other possibilities. Now, we also love being developer friendly. We love our community and the fact that we are open source. Now, since the topic of the call is building GenAI apps, naturally comes the question of where does Memgraph fit into the whole GenAI story? What capabilities and features does it offer? And what are the main strengths of Graph in the RAG system in general? So most common use cases of GenAI apps involving LLMs are the Q&A types of use cases. So with the knowledge graph structure, your graph already tells a story stored in the triplets. So you are already achieving relational context behind your data. So having retrieval strategies specific to graphs, such as community detection, can improve your retrieval accuracy. You also have the ability to traverse to data neighborhoods, and you can scan the subgraphs instead of full data sets and then achieve the retrieval efficiency with that. So when you also have real-time data coming in, if your app involves an LLM, it is important to have the dynamic knowledge with the real-time updates. So you can feed that updated knowledge back to the LLM. Now, for the more specifics about what I just talked about, here are listed some of the features that are really useful when you're building GenAI apps, such as deep path traversals, the known BFS and DFS traversals, and the other algorithms such as community detection. So all of those algorithms help retrieve relevant data from your knowledge graph, which is then being forwarded back to the LLM. We've also recently added the latent community detection, which was proving to be a better and a faster version of the Louvain community detection. And we also have a new feature coming out, which is vector search feature, and it's coming out very, very soon, meaning tomorrow, with the new version of Memgraph. So make sure to download that, to test it out, and try it. We are really looking forward to that as well. Now, besides the algorithms, there are also some very useful tools and integrations we have, such as a GraphChat tool in Memgraph Lab, and of course, the integration with the LlamaIndex. Now, the GraphChat is a Memgraph Lab feature which allows users to interact with the database using a natural language. So you can ask your database a question, it will then generate Cypher queries using LLM, and it will summarize the results of the Cypher query and to get you a final response in a natural language as well. So we actually talked about the GraphChat feature in depth in the previous community call with Katarina and Tony. And Tony gave a great overview of the feature. He gave a great demo example on how to use it and how to leverage its capabilities. So make sure to watch this after this, of course. Now, when it comes to the integration with LlamaIndex, the main start of the show, this integration came after we did a lot of the research when we got into the whole AI story. And of course, with the research, we wanted to see which feature or which tool the users use a lot. And of course, LlamaIndex was popping up everywhere and a lot of the people were using it. And I wanted to test it out. I tried it out. I loved it. And I wanted to see Memgraph as one of the graph stores in LlamaIndex. So that's exactly what we did. I implemented Memgraph there, and thankfully the folks from LlamaIndex were really responsive, and we made that integration happen very quickly. Now, for the overview of what exactly is that integration. So for the beginning, we have some kind of an unstructured data. That unstructured data could be some sort of a file. And in the example that I'm going to show later on, that will be a textual file. So you want to convert that unstructured data into a knowledge graph using one of the LlamaIndex's graph constructors. And then you store it in Memgraph. So Memgraph here acts as a data source. It's a central hub for LlamaIndex's graph data. And then if you have your data in Memgraph, you can either query it, you can just store it there, you can run some algorithms on top of it, or just have it as a data source. And what you can also do here is you can also use LlamaIndex again to query dynamically using one of the retrieval methods. I'm going to mention one of the retrieval methods, but Laurie also mentioned having a vector retrieval there. Now, this is a pipeline of how the pipeline works. So this is similar as what Laurie was talking about. So first you have some unstructured data. And here I'm mentioning the text file because that's what I'm going to use in my example. Now, with that data, we want to chunk it. And from those chunks, we want to extract some entities and have everything stored in Memgraph. How we are creating the graph is we are using one of LlamaIndex's graph constructors. In this case, is going to be a schema extractor. I'm going to talk more about that a bit later on. And then after we construct that graph, we have a knowledge graph in Memgraph. Now, as I said, you can just keep it there. You can query it, but what you can also do is you can use, again, natural language to query your data. And then with one of the graph retrievers, in our case, it's going to be the LLM synonym retriever, you're going to receive, again, a response about your data set in a natural language. So here you can see the example of what I was talking about, the usage example. I think it's very simple. It's straightforward. After you install all of the initial packages, you have to define a graph store. And before you do that, make sure you have Memgraph running in the background because we're going to establish a connection between a running Memgraph database and LlamaIndex. So to establish that connection, you have to define a graph store. It's defined by setting the 3 variables only, so your username, password, and the URL. Username and password are going to be by default empty strings if you haven't defined it otherwise. And just you have to specify connection URL and you have established that connection. So I think that is pretty straightforward there, and we made it happen. We made it simple to use. And after you have that connection, the next step will be to load your data. In this example, I'm using the textual file about Charles Darwin, which is stored in the data directory here. Now, with the simple directory reader from LlamaIndex, I'm loading the data and I'm storing it in the documents variable. Now, that variable is going to be passed on when we are constructing the data. So regarding the graph construction, we already mentioned the schema LLM path extractor, and I decided to use that here because it has great ability to predefine schema. So you can both choose to predefine it or not define it. So if you define the schema, the LLM is going to follow it strictly, so it will create the graph with only the entities and relationships that you defined. So here we have an example of how you can do that. And if you decide to do that, you can pass some of those variables as well to your property graph, to your graph constructor, and when creating the property graph index. Now you can see here that I'm passing on a documents variable, and here I'm just defining the LLM model that I want to use. I'm using the OpenAI GPT form. Now, if you decide to define the schema, that would also be here or passed on here. And what else you can do is you can define the maximum number of triplets that are going to be created from a certain chunk of the data. So after this step, our knowledge graph is created. And here I decided to give an example of how one chunk would look like in Memgraph. So after you import your data and create a knowledge graph, you can see that we have a node chunk, which has all of the text from the chunk stored. And from that chunk, we have some entities extracted. In our case, that is Charles Robert Darwin. So we have both the entities from the text and the contextual data from the text stored in the chunk nodes. And now from here, as I mentioned, you can just leave it as is and use your data in Memgraph. But what you can also do is you can query directly by using one of the retrievers that LlamaIndex provided. So here you can see an example of a question we gave to the query engine, such as who did Charles Robert Darwin collaborate with? Now, what LLM synonym retriever does is that it takes the query, it generates keywords and synonyms, it finds all of the relevant nodes using the exact keyword match, And then it returns the direct neighborhood of identified nodes. So it does the one hop in a graph. Now you can then, the LLM scheme synonym retriever translates the results into an answer, and you then receive an answer to your question. In our case, that would be the Alfred Russel Wallace. Now here you can already see some of the issues we might possibly have in constructing data, and those are already well-known issues in the LLM world, including the LLM hallucinations. And here what I listed is the entity resolution issue. So deduplicating your data, basically. What can happen here is if you have a piece of text, let's say a text about Charles Darwin in our case, and the one chunk contains the name Charles Robert Darwin, another chunk contains Charles Darwin, then we can have just Darwin or just Charles. You get what I mean? You can have the same entity, but called multiple different names. And then when you create that knowledge graph from those chunks, you possibly can have separate knowledge graphs. So as you can see here, we have one graph for Charles Darwin, and we have another one for Charles Robert Darwin. Of course, those are the same entities, but LLM doesn't know them. So what could happen here is, let's say we want to query this graph, we don't know that it's not connected properly, and we want to find out some information about Charles Darwin, let's say about his death. And then in the left graph, you can see that we have an entity and relationships that Charles Darwin died in Westminster Abbey, so he was buried there. And in the right graph, you can see that he died in 1882. So we have two different graphs with two different information about its death. But if you were to query it, you were going to have one of the results. So in order to have the full context, we want those nodes to be merged. Now, you can solve this issue with either pre-processing your data or post-processing your data or using some kind of external tool. I'm sure that there are some tools that are dealing with deduplicating the data now. But basically, with the pre-processing, you would pre-process your unstructured data. So you would do that in that step. If you decide to post-process your data, you're going to do that within the Memgraph or with your graphs. So you're going to try to merge the nodes based on some kind of a similarity. Now, that's all the stuff that we have to take into consideration and maybe need to have some kind of a human input. LLMs are not human enough already, so I mean, thankfully. So we still have to do some of the manual work in the meantime. But yeah, one of the next steps and improvements we're planning on doing is actually to limit that and to have and to utilize the new vector search feature that is coming out tomorrow, actually. And we want to implement the vector store index in LlamaIndex as well. So we want to have that as one of the possible retrievals. Now, we want to also optimize the current queries, and we want to make them faster and better by utilizing the show schema info that we have in Memgraph. So with the show schema info, you can basically get the entire schema within the query and then use that to either refresh or pass on to LLM. I've left here 3 dots because who knows what could happen in the meantime, and who knows, like if, after the research, if you find out some more ways to improve our integration and to optimize it. But yeah, everything is possible, I guess. And that will be all. Thank you so much for the attention. You can join us on Discord. We have a pretty active community there, and we love hanging out and answering all your questions. And if you wish to check out the usage example or the similar example I just showed, you can see it in the Llama docs, LlamaIndex docs under the example in the property graph. So thank you all, and I hope this was useful and insightful to you. And let me know if you have any questions for either Laurie or me.
Thank you, Matea. This was great. Let me just get us all back to the main stage. And now, Matea, you're the only one in the left. Okay, that's cool. Yeah, thank you both for the great presentations. I enjoyed it. Laurie, you really gave us a great overview of what you do at LlamaIndex. I mean, you do a lot. We just focused on, let's call it one really small part and with the graphs, and you do a lot of other things. So thank you for presenting that. And Matea, thank you for getting us into the world of graphs and knowledge graphs. And I see we have a question related to that Laurie already answered. But Matea, just for the awareness, it was related to schema, LLM path extractor, and does it extract properties and set them to the entities and relationships? So Laurie said yes, luckily, yes. LlamaIndex does a lot of things. Do you have something to comment on that, maybe?
Yeah, it doesn't do it by default, which surprises some people, but it does do, you can get it to set properties on your entities.
Okay, cool. We have another question related to, this is probably more for Matea, related to the differences between Memgraph and Neo4j. So having them both being graph databases, what is the main difference there? And maybe like in the question, it was like, what is the upper hand of Memgraph here?
Yeah, I would say that definitely the upper hand is performance. So since Memgraph is an in-memory graph database, you can achieve a much more better performance with that. So you don't have to store your data on disk. You have everything in memory, which makes it much faster. So I would say that performance is definitely our main advantage here, as well, along with the other ones.
Yeah, I would like to say mainly this dynamic environments and having the ability of having everything updated on the fly as your knowledge grows is maybe one of the biggest advantages of Memgraph. And for that, we implemented dynamic algorithms such as dynamic community detection or PageRank that you can utilize. So that's maybe the biggest difference. And of course, our wide community and being open source, so you can just run it, play with it, and build your own application with LlamaIndex and Memgraph both. We have another comment on the model, and this is an interesting one. So Matea, in your model that actually was created by the LLM, you had die in and then year, and the user said it's better model as a property of the person than another entity. So it's cool to being able to have the schema LLM path extract properties and set them. So yeah, it's not an easy task definitely to create a knowledge graph, and we have a lot of questions regarding that, and there are a lot of pre and post processing involved to make it ideal, but definitely knowing what your data is about, I think, is really helpful to have the best possible RAG as well.
Yeah, definitely. And in this example, I left defining the schema to the LLM, so that's one of the reasons as well. You can also define the schema yourself and maybe cut out all of those outliers and maybe just adjust it based on your use case.
Yeah, and we have another example, like who have any demos of updating an existing knowledge graph, and this is just something that we were working on recently, I think. Matea, any comment on that? I mean, it's not out yet, but yeah.
Yeah, definitely. You can just update your existing graph. You can pull out all the information, or you can just add on to that as well. You have the ability to pull the schema and then just do the new updating data based on that schema, or just create a new knowledge graph from the updates. And also LlamaIndex has the possibility of using the from existing. So that's a procedure that utilizes the already existing database and then just tries to query the data from that. I'm sure Laurie will have much more information, but I know it's a possibility.
Nothing to add to that.
But yeah, regarding the demos, we will send over later. So we are in the process of creating Jupyter notebooks for those stuff. So definitely a good idea to add the demo of updating an existing knowledge graph. We have actually a demo of updating, just updating a graph, expanding like a structured data with unstructured. So we do that, but it's still not out, but we will let you know as soon as it's out. We are in the process of doing that. Maybe one question from my side for Laurie would be, I noticed you mentioned some of the basic RAG downsides and like users having issues with that. Did you notice what kind of use cases are looking for a GraphRAG? Well, like what is the point when people say, okay, but basic classic RAG is not enough for me and I need a GraphRAG? Did you notice from like different people asking you about that? Or, like, what is the key point there?
That's a good question. I would say the best time to use a knowledge graph is when you've already got a knowledge graph in existence. Like what the information that you have is already graph based. If you've got a complex relationship between entities that isn't going to be revealed by semantic search, then that can be the best one. So some of the examples I've seen were somebody was doing an application that shows you how to service cars. And they had a graph of all of the parts of the car and how they relate to each other. Like this part is part of this thing and it fits into that thing and they collect into, and that was a really amazing use of it. It was, we already have this graph of how all of these parts fit together, and we can use that as, you can use text to cipher to query that graph and figure out how these parts need to be changed and how you're going to fix them.
Yeah, definitely. That's a cool example. And as you said, like having a knowledge graph already makes it so much easier without having to actually construct the knowledge graph. But having this with Llama was so much easier for us when we were working on our demo. When Matea was doing Jupyter notebooks and similar, because like she could just run everything from Llama, didn't have to struggle with all of the other external tools. So that was cool.
Great.
Yeah, I remember my first revelation when I did a graph construction part and the property index creation, and then I went to Memgraph and I saw graph and I was like, that's it, like graph is created already.
Yeah,
we try
that's
to make
really
it
cool.
easy.
Yeah, you definitely do, definitely. And I must say, like, kudos to all of the LlamaIndex crew, because like it was so easy to kind of get started, to contribute. You were really prompt on that side, and thank you for doing that and for allowing us to adding our integration there. They're so quickly.
Okay. We love having integrations. We love having partners to work with. That's why we exist, is to be an open source project that connects everything to everything.
That's really nice. Okay, I think that's it. Then we can wrap up. I'm just sending everyone an example that Matea created on LlamaDocs that you can actually run by yourself, creating Memgraph property graph and everything that she talked about today. If no one else has anything else to say, I think that's it. Thank you both, Laurie and Matea, for joining and presenting today. Thank you everyone who joined. And you'll be able to watch the recording afterwards. And that's it. Until the next community call, probably in the next year, but we'll see.
Thanks, everybody.